welcome to another episode of Links Digital online series, OpenCV with Python. And today we'll be looking at how we can put a mask inside a mask. So for example, you want to mask an object, for example, a face, and how you can detect only eyes if they exist within a face. So this will be something that we'll use later on where we want to do more elaborate detections of traffic lights. If we see traffic lights, you want to see if it's a red light or it's a green light. So you isolate the area that you want to find. So I think, for example, in a normal frame, you see like maybe there are red lights from cars, there are red lights from maybe someone holding a torchlight around or something. So there are different ways or different items that will emit red light, but we only want to track red light from a traffic light. So this one way we can do it. So we identify the rough shape of a traffic light. There'll be a bounding box that is drawn around it. After that, we will look for the color of the light on the traffic light. Right, so let's get to it. And for now, we don't have a trained traffic light classifier yet. So we'll be using the face example. So yep, we have face initially, and make sure that your files are in the same directory. So your file Cascade frontal default XML is in the same directory. So if as your Python file. So if everything is on the desktop, make sure all the files are on the desktop. If not, you can create a new folder and put all the files into the one folder. Yep. Right, so we'll look at creating another cascade. So the front part is really simple. You just follow the format of initializing and giving a name to the classifier. So we have it here is cascade I. So just take this cascade I. This, and we will comment out traffic light first. And now we'll look at. So whenever you see the faces, you can just create a new variable and then eyes. Yes. So we're applying the cascade onto the grayscale image. And over here, we will and here, we want to detect only eyes that exist within face. So we will do a nested for loop. So we'll do this, draw the bounding box around it, and we'll do this. So we have to indent it further. And then we'll just detect it. This is just for detecting from a range, so we don't need this. So now we're having two different sets of coordinates. So we have to label them x1, y1. So this one is going to have 1 to it. This, and this one will be 2. This, and the box for each eye will be the same size, and this will also be 1. Right, we've got everything covered. Like this one, 1, and yep, we're done. Alright, so this is face. Let's go with this, and now we can just see what we get. Just run the file and see what we get. Right. Okay. Right, so you can see faces, it must have eyes within the face. The eyes appear outside your face. So we can just take a figure we have here. You recognize this. Yes, it does recognize the face. Yes, see, if the object's a little small, sometimes it's a bit hard for it to recognize the mini features such as eyes on the figurine. If you put it nearer, yeah, she does recognize the eyes pretty accurately. Yep. So another thing that we can see from this or notice is the size of the bounding boxes. So if, for say, like I'm staying at this frame or this distance from the camera, we know that the eyes will be roughly drawn around a certain size of bounding box. So if we want to filter out all the little erroneous results we're getting, we can set certain limits on the height, on the width, or which position we want to be considered as an eye or an object that we are looking for. So that's how we can do further classification beyond just identifying these images. Right, so to close it, and yeah, that's about it. So moving on from this, we'll be looking at how we can detect other objects. We're moving towards road settings and using all these layered loops, for loops, and if to find certain objects. So if you're looking for the code for today's session, you can find it in the description below. If not, see you next time.